All right, the derivation of the law of cosines. So I have a triangle here with 3 different length sides, 3 different angles. I'm just basically going to split this one down. And I'm going to label this distance here h and this distance here x. So therefore this distance here would be b minus x. So b is the length from here to here. That's b. I know from Pythagorean theorem, I know that c squared is equal to h squared plus x squared. A squared is equal to h squared plus b minus x squared. So if I go ahead and multiply that out, this is equal to h squared plus b squared minus 2bx plus x squared. So a squared is equal to h squared, just rearranging the formula here, bringing this over, plus x squared plus b squared minus 2bx. H squared plus x squared, that's just c squared. So a squared is equal to c squared plus b squared minus 2bx. Now in terms of x right here, if I'm looking at this triangle right here, so I've got the triangle, this is alpha, this length distance here is x, that is h, and that is c. Not doing Pythagorean theorem here, doing right triangle trig, because this is a right angle. This line right here I don't think I stated explicitly, but this is perpendicular to the bottom one here. And so the cosine of alpha is equal to the adjacent over the hypotenuse, which is c. And so x is equal to c times the cosine of alpha, multiplying both sides by c. And so now we just make the substitution here, and so we end up with a squared equals b squared plus c squared, just changing the order around, minus 2 b times c cosine of alpha. And that's the derivation of the law of cosines. So, good times.